Hey there, and welcome back. We are going to start solving some mainly logarithmic equations and doing some more things now in here, section 8.4. So, if we got two logs equal to each other, log base b of this equals log base b of that, that means this has to then equal that. Same way we were doing with our exponent stuff the other day. So here we've got to make sure bases are the same, they are. So that means x then has to just equal 21. Uh, So here we got log of this equals log of that, so this then has to equal that. So I'm going to subtract my x and add my 12 and get x equals 19. Same thing here, we got log base 2, log base 2, so this has to equal that. 4x minus 3 then equals our 2x plus 7. Subtract my 2x, add my 3, gives me 10. So x then equals 5. Wonderful. Alright, here I got log base 3 of this stuff, but I got a 2 here. I need to take that and put it in here as one of my exponents using our powers from before. Now I've got log base 3 of both things, so x plus 2 is going to equal 4 squared. So x plus 2 equals 16 and x equals 14. Alright, so what happens when we got all kinds of crazy mess going on? That's where we're going. On our right side here, I got two different logs. I need to put those together, do my condensing that we were talking about just yesterday or day before. So I can get log of my 3x then equals, here we're going to have log of 5 times x minus 2. Putting these two logs together, taking this times that. Now I can kind of get rid of my logs and just say 3x then equals, I'm going to do my distribution here, 5x minus 10. I'm going to subtract that 5x and get negative 2x here equals negative 10. So x then equals regular old 5. Yeah, fun. I can tell you're excited that you're like, man, I'm totally going to be able to do all this. And you will. It's not that bad. Alright, so over here I got to put these logs together, which means I need a log 5 of 25 times x minus 4. This side's going to stay the same for the time being. So now I can drop my logs since they are the same and say x minus 2 equals 25 x minus 4's. Distribute, so I got x minus 2 equals 25x minus 100. Now I'm going to subtract that 25, get negative 24x, and add that, makes negative, 98. So when we divide, that don't go in evenly, but it's going to be positive, and what's that? Half of 98 is, what, 49? And half of 24 is 12. So 49 twelfths. That's a fun number. Alright, so now some log equations have just one log over here. Now these ones we can kind of use what we were doing before and take my 2 to the 5th power equals my x. 2 to the 5th equals x. And that's not too bad. That's using that same thing we were doing before where our base to our power equals our answer number. Then we might want to look back at what 2 to the 5th power I think is, what, 32 if you go check your front page there. So 32 it is. So here, we're going to go 3 squared has to equal x plus 1. So we got 9 equals x plus 1, so x then has to equal 8. Oh, not so bad, not so bad. Uh-oh, something new. Now we need to condense and rewrite. I don't know that this is going to work for us. This might be too much. Alright, let's get this up here out the way. I need some room. Alright, so let's first, base 9, let's put these together. We got log base 9 of 5x equals 1. Wait, this ain't so bad. 9 to the 1 power then has to equal 5x. It was 9 to the 1, this is just 9. Divide, divide. So 9 over 5. That's it. Wow. And you got scared for nothing. Alright, let's put these two guys together. Natural logs going on here. So we got ln of 8x has to equal 0. Oh, wait a second. What's going on here? Remember, natural logs really got an e down here. So we're going e to the 0 has to equal 8x. E to the 0 equals 8x. What does anything to a 0 power equal? That's the worst 0 I've ever seen myself try to not make. Let's try that again. 0. Anything to 0 power is just 1. So that's really 1 equals 8x. Divide by 8. And we got 1/8 for what x equals. Alright. So before we were solving things with our exponents. So this is just kind of a revisit of that. How do I change this over to the same base? Well, that's going to be 7 to the x plus 2. And 243 is the same thing as 7 cubed. So then we were able to take our exponents and say x plus 2 equals 3, so x equals 1. And that's kind of what we were doing before. Now, here, this is really getting to what logs were really created for. 7 to what power makes a 5? Who knows? It's a disgusting little decimal, I'm sure, right? Because it got smaller. But what is it? I don't know. So what we need to do is we're going to go through some steps here. We're going to log both sides. You can use log or natural log, whichever one makes you feel good. If there's an e in the problem, I would suggest using the natural log because it can make it go away. But other than that, regular log's fine, natural log's fine. You're going to use your properties to kind of put some stuff together, move them around, and see what you can do. And then you're going to divide both sides by whatever you got. So here, we're going to take log of both sides. Log of 7x equals log of 5. So it's kind of the same thing as like multiplying both sides, adding both sides, square rooting both sides. We're going to log both sides. Now, the whole reason we want to do this is we want to get our exponent so we can use it, right? So we're going to take that exponent and drop it out front. Now I got x log of 7 equals log of 5. Well, that made things nice because now we can just divide by log of 7 on both sides. And look at what we just solved for x. It's log of 5 over log of 7. It ain't pretty, but that's what it is. So we got x equals log of 5 over log of 7. So let's try that again here. I'm going to take log of both sides. Log of 5 to the 3x equals log of 4.9. Yeah, because who would want to solve this without logs? It's a mess. So we're going to take that exponent, we're going to drop it out front. We got 3x, whoops, log of 5 equals our log of 4.9. So now I'm going to divide by not just my log 5, but I want to divide by that 3 as well. So I can get that to cancel and all this to cancel. Just leave my x. So I'm going to divide by 3 log 5 over here, and that's our answer. Log of 4.9 over 3 log 5s. And you can put that 3 back in here and make an exponent if you want. You know, it's up to you. But I think that's a good answer right there. Alright, I got my e. That means when I do my logging on both sides, I want to log e, which is our natural log. Oh God, I am not doing well with these things today. That's a 4x equals natural log of 2. So now, when I bring that 4x out here, I got 4x natural log of e equals log of 2. But what is the natural log of e? That's one of our properties from before. It's really log base e of e. And when you have that, it's just a 1. So this really just goes away. So we really just got 4x equals natural log of 2. Divide by 4. So x equals ln 2 over 4. Done. Alright. So here we're going to log both sides. Bam. Log them both. Let's get that exponent out front. So this whole guy is going to bounce out here. X plus 8 times my log of 5 equals my log of 7. Now what we're going to divide by here is not 8 because it's inside the parentheses. We've got to divide by log of 5 first. Take it out. So it's gone. I got x plus 8 equals log of 7 over log of 5. How do I get rid of the plus 8? I subtract 8. So get minus 8 over here, and that's our answer. Log of 7 over log of 5 minus 8. And hey, I think we're almost there. We're almost there. Alright. Hey, is this the last guy? I think it is. It's got an E on it, so I'm going to natural log both sides. Hope some great things happen. Oh, don't forget those parentheses. They're helpful. Now, what do we know about natural log of E? It goes away. So this is just x minus 1. Natural log of 7. And man, this got easy. Add 1, add 1. So we just got natural log of 7 plus 1 is what x equals. Awesome. This highlights another reason why parentheses are great. If I had parentheses around the 7 plus 1, that means it's natural log of 8. But without the parentheses, that means my natural log stops right here at the 7. And that plus 1 is something we're doing afterwards. So it's a little thing, but it's a big deal. And hey, look at that. We're solving log equations. Never would have thought you were doing that a week ago, right? Anyway, give those practice problems a try in a class, and hopefully make some good choices with your logs and do great things with yourself. We'll see you in class.